All right, so second part of 4 notes here. Um, Again, we wrote down the -5 and 1.5 as our x-intercepts. So let's go on to our other graphing problem here. Try this out with me. So move everything over on the left-hand side. So I'm going to add 19x, add 19x. They're not like terms, so I just have to write them down. I'm going to bring -15 over, so I'm going to add 15 to both sides. Then I get 6x squared plus 19x plus 15 equals 0. Now I can plug that into my graphing calculator there. So I'm going to go to my y equals here. Clear that out of there. I'm going to put in 6x squared and plus 19x minus plus 15. Plus 19x plus 15. Oops, it's not plus 15. Plus 15. 6x squared plus 19x plus 15. Good. Graph. Huh. Looks like I'm only getting 1 there. So I want to double check what's going on here. 6x squared plus 19x plus 15. So, oops. Whoa. Let's clear that all out of there. 6x squared plus 19x plus 15. Graph. Graph. There it is. So now that I've got it nicely done, I can go second calc. And notice this one here, there's only 1 point. It's sitting right there on the x-axis. So we know this time we're going to get 1 solution. So again, we're going to do exactly what we did before. We're going to go ahead, and we've got it sitting there, right there. The point is right there on the x-axis. We're going to go to the left, to the right of that point. So I'm going to go second calc, go down to 0 or root or x-intercept. It's saying it's way up there at 0, 15, so I need to bring it down, so I got to use my left arrow. Bring it around. I'm on the left side now. I'm going to hit enter. I'm going to bring it over to the right side of the point. I'm going to hit enter. Enter one more time. It's telling me it's -1.5. So x equals -1.5. So next one here, example 3. The function h equals -16t squared plus 48t gives the height of a tennis ball t seconds after it hit. Ignoring the height of the tennis player, how long does it take for the ball to hit the ground? So the ball's going something like this, a path like this. They want to know how long does it take. That's time. This is time t. So we want to know what this distance in here is. This is t, from there to there. So the ball kind of followed that path. I'm going to redraw it out. So it hit down here at the ground, and this is t. So a certain amount of time that's gone through here. So we want to know what it is. It started here at 0, and then it landed over here. And we want to know what that value is. So let's figure that out. So to be able to do that, we can just plug this into the graphing calculator, except we're going to punch it in as y equals -16x squared plus 48x. So let's do that. So notice it's going to be upside down as well, because you got that negative there in front this time. So I'm going to clear it out. -16x squared. And I think we said plus 48x, but I'm going to double check. Plus 48x. Hit graph. There it is. So again, we're trying to figure out this point right here. We want to know what that point right there is. So we need to be on the left side of the graph and the right side of the graph. So when it's upside down like that, I'll draw it out over here. The graph is doing something like this. We want to find this point here, so this is the left, and this is the right. Not really going to go right below the ground there like it is, but we still got to do that to find our value. So we're going to go down to 0. We're going to move our cursor. It's got to go up. So I'm going to use my right arrow. You can see it's going to go up. You can't see it right. Oh, there, it went too far. I should probably get those red marks out of there so we can actually see the cursor there. So now that's on the left-hand side, so I'm going to hit enter. Come down here on the right. It's jumped way down here by the -8. Hit one more time. It'll tell me it's 3. So it took time, ended up being 3 seconds for it to hit the ground. So then if you remember domain and range, domain is all possible x values. In our case there, it's our t values. So we use these symbols in here. T is greater than or equal to something, and t is less than or equal to something. Well, time here starts at 0 here, and then it lands on the ground over here at 3 seconds. So we go from 0 to 3 here. And so we are looking at time here. So look at your leftmost point. And this is your rightmost point. And so most likely they're going to be on the x-axis, and this is rightmost point on x-axis, because that's where it's going to hit the ground. This one here is actually going to be somewhere on the y-axis. That's going to be where it is. It's typically 0. For time here, we usually start at 0 time. So this is almost every single time he's going to start at time 0. And then our range has to do with our height. We're going to use the same symbols. The height starts off usually at a certain height here. In this case, it's going to just be 0 because we can see our height there is 0. So that's going to be the x-axis. So on the axis there, so it's going to be a y value. So then our other one that we looked, so we looked the bottommost point here. So this is the bottom. Which is typically 0. And then we want to find the topmost point, which is at a vertex. And we're going to look for the y value of the vertex. So to be able to get that, we could probably just use negative b over 2a. So I'm going to do that. So t is equal to opposite of b over 2a. Well, our b value, if you remember, it goes ax squared plus bx plus c. And ours is negative 16t squared plus 48t. And there isn't a constant value, so it's just 0. So my b value there is 48. So opposite of 48 is negative 48. Divided by 2 times negative 16, which gives me negative 48, divided by negative 32 there. And you can simply do that out on your graphing calculator or your calculator there to figure out what that value there would be. So negative 14, I'm going to plug that in my calculator right now. So negative 48 divided by negative 32, 48 divided by 32, I get 1.5. So it's going over here 1.5 and then up something here. So my order pair is going to be 1.5. To get the other value, you got to plug it back in. That t value, you got to plug back in here. So h equals negative 16 times 1.5 squared plus 48 times 1.5. So I plug that back in, negative 16 times 1.5 squared plus 48 times 1.5, and I'm getting 36. So the lowest height there is 0. That's where it hits the ground. That's where it started. Started there at 0, or where it landed over here on the ground here is at 0, and it went up as high as 36 feet. So from 0 to 36, and I keep saying feet. It doesn't tell us that it's actually in feet, but I'm assuming it's feet. So there is our domain and range for that function. All right, so that concludes the video for 4.4. And you can start working on 4.4 worksheet if you want.